Welcome back to my channel Cloud DevOps Era. In today's video, we are going to discuss about two major services provided by AWS Cloud. Those are load balancer and auto scaling services. Using these two services together, you can automatically distribute and maintain the right number of EC2 instances to handle your application's load efficiently. So let's understand these two services with an example. In this load balancer service, we have multiple load balancers like application load balancer, network load balancer, and gateway load balancer. This application load balancer works at layer 7 of the OSI model, and it is mainly recommended and used for HTTP and HTTPS traffic and path-based routing. And coming to the next type of load balancer, that is network load balancer. This load balancer works at layer 4 of the OSI model, and it is best for high performance and low latency. This network load balancer uses TCP, TLS, and UDP ports. Coming to the third type of load balancer, that is gateway load balancer. This gateway load balancer type is mainly designed to deploy, scale, and manage network virtual appliances like firewalls. When we are going with the practical explanation, you will get better understanding about this type of load balancers. The next service, that is auto scaling service in the AWS cloud. This auto-scaling service is mainly used to automatically adjust the number of EC2 instances based on the demand. So now let's take a simple example to understand how auto-scaling service will work. Suppose you have hosted an e-commerce application on your EC2 instances with two servers. So in the normal days, your application will work fine with two EC2 instances and user can access without any issue. There will be a scenario like in festive season, you have announced 45% of discount on your e-commerce products. At that time, you can expect large number of traffic audience accessing your application. So you can expect more traffic than the usual days. In that case, your application might go down due to the heavy traffic from the end users. So in this case, AWS introduced a service called auto-scaling. This load balancer will distribute the traffic from the users to the EC2 instances evenly using the round-robin method so that users can access the application without any issue. So now let's go to the AWS console and create services over there. This is my AWS console. Click on EC2. Click on launch instance. Provide name to the EC2 instance. I'm going to create two EC2 instances with same configurations. Select Ubuntu AMI. I'm selecting T2 Micro as my instance type. I'm going with the existing key pair. If you want to create new key pair, you can click on create new key pair, and here you have to provide your key name. And once you click on create key pair, you will be having private key in your local machine. So coming to the network settings, I'm going with default VPC. Coming to the security groups section, we have to allow 22 for SSH connection and 80 port for HTTP connection to access our application through internet. For now, I am going with the default configuration storage settings. If we go to advanced details section, here we can see the user data. As we are deploying a simple application to fetch the details from the server, we are going to use the Nginx web server to host our application. So we have to install Nginx in our server. So now I'm going to add the script over here. This script performs multiple tasks like updating the existing packages in Linux VM, and it will install the Nginx web server, and it will start the service, and this is the content that I have to fetch from the server to get the server details. And once it is updated the content inside this file, it is going to restart the Nginx service. This all operations will be done at the time of system is getting started. Now click on launch instance. Here we can see our instances got created successfully. Go to instances section. Here we can see two VMs that we have created just now. It is running. We have same names over here. Let's change the VM's name. Here we can see our instances are up and running. It will take some time to complete the initialization process. Meanwhile, we'll copy this public IP to access our application which is running in our Nginx web server. Go to new tab, paste the public IP. It is showing that it is not secure. So let's continue to the site. Here we can see we have got the server details. We have received the private IP and its region and the static message. So if you cross check the private IP, it is ending with 11-103. So here we can see the same IP ending with 11.103. So let's check the connection of VM2. Copy this public IP. Private IP is ending with 3.54. Now go to new tab. Here we can see ending with 3-54. So before going further to create load balancer and auto scaling service, let's create an image template which will be used while creating the auto scaling servers. Now select a VM, go to actions, click on image and templates, click on create image, provide the image name, leave the default settings as it is, click on create image. Our AMA image was created successfully. Now let's go to the load balancer service. Go down and select load balancer. As of now, I don't have any existing load balancer, so let's create a new load balancer over here. Here, these are the different types of load balancer that we have discussed in the starting. Based on our requirement, we can select one of those. For now, I'm going with the application load balancer. Click on create. Provide the load balancer name. Here we can see some detailed information how application load balancer works. We have to select it as internet facing for our load balancer. Select IPv4. And as I created my VMs in my default VPC, I'm going with the default VPC. Now coming to the availability zones and subnet, if we can see here our EC2 instances that are created in AP South 1B availability zone. So here we have to select the AP South 1B, and we can also select the remaining availability zones as well. That will not affect anything. So coming to the security groups, this is the security group that we have created while creating our EC2 instances. We can select multiple security groups as well. Here we have to select HTTP port as our listener. If we select HTTPS port over here, it will ask the SSL certificate details. So as of now, I'm going with the HTTP. We have to select the forward to target groups. We have to create a target group. We have to keep the target servers in the target group. So let's create a target group. So we are going to point our EC2 instance in our target group. Here we have to select EC2 instances as we are keeping these instances in our target group. So based on our requirement, we can select one of those. Currently, I am going with instances. Provide the target group name. Keep the default settings as it is. Now here coming to the health checks part, we have to provide the root path. So if we go to advanced health checks, here we can see healthy threshold, unhealthy threshold. Here why we have given 5, because it will check the instance's health for the 5 consecutive times, and if it gets the response from the instance, it will shown as healthy, and it will check the unhealthy status 2 times, and if it is not getting any response from the instance for 2 consecutive times, it will be shown as unhealthy state. Each time it will take 5 seconds to check the health of the instance. For every 30 seconds it will be checking the instance's health. Click on next. Here we can see these are the 2 instances that we have created earlier. Now here we have to select these 2 instances. By checking these 2 instances, we are keeping these 2 instances in the target group, and the load balancer is going to point the target group. Now click on include as pending below. Click on next and click on create target group. Here we can see our target group was created successfully. It will take some time to get the healthy and unhealthy status. Meanwhile, go to load balancer and refresh over here. Now here we can see this is the target group that we have created just now. Now select this. Now leave the default settings as it is. Click on create load balancer. Our load balancer was created successfully. Now here we can see it is still in provisioning status. After provisioning, we can access our EC2 instances using this load balancer URL. I'll be back once it is completed provisioning. Now here we can see our load balancer status was active. Using this load balancer URL, we can access our 2 EC2 instances. Now copy this URL. Now once we paste this URL over here, click on continue to site. See, this load balancer is pointing the EC2 instances that we have created. Now if you observe over here, this private IP will change while I am refreshing. Here you can see 11-103 and 3-54. So this is the load balancer that is distributing the traffic to both the servers. So in real time we'll get a static content while we are refreshing again and again. So to check the differences how the load balancer is going to work, I have added these details. It will change while we are refreshing one by one. We'll go back to the AWS console and let's create auto scaling group over there. Click on create auto scaling group. Provide the auto scaling group name. I have existing templates. So click on create launch template. Provide the name. I am providing the same name in the description as well. Now we have to select here AMI. Here we can see my AMS option. Now select this. Here this is the AMI that we have created. Now go down. I am selecting my existing key pair. Now select the security groups. Now go to advanced details. Here we have to provide the user data as we have provided earlier to our EC2 instances. Click on create launch template. Our template was created successfully. Now go to auto scaling group tab. Refresh over here. Now this is the template that we have created just now. Go to next. Now click on next. Now here go down. Select the default VPC and select the all availability zone in that region. Click on next. Now here we have to select the attach to an existing load balancer. Select choose from load balancer target groups. Click on the drop down and select the target group over here. And here we have to turn on the elastic load balancing health checks. Click on next. Now here we have to provide the desired capacity, minimum desired capacity and maximum desired capacity of our instances. Now I am selecting desired capacity as 2 and the minimum desired capacity should be equal to the desired capacity. So provide 2. So maximum I am keeping 9 servers. Now here we have to select the target tracking scaling policy. Here we can see we have different metrics. Here if we click on this drop down, we can see multiple metrics. Now currently we are going with average CPU utilization. So here we have provided the target value as 50. This tells us when the CPU utilization reaches 50%, it will spin up the new VM and so on. And when the instance's CPU utilization was decreased below 50%, it will terminate one by one to save our cloud cost. Here we have to select the instance maintenance policy. Based on our requirement, we can select one of those. For now, I am leaving as it is, as no policy. Now go down and click on next. Now here we can add the notifications. If we want to get notifications while our instances got creating and terminating, we'll receive notification through SNS service provided by AWS. These are few events. While any one of these events occurs, we'll get notification. So if you want this feature, you can add the notification. For now, I am removing the notification. I don't need this. Click on next. Now click on next again. Now review all the settings. Click on create auto scaling group. Here we can see our auto scaling group was created successfully. And here we can see 2 instances and 2 desired capacity. Here we can see 2 minimum and 9 maximum instances. If we click on this auto scaling group, we'll get all the information about that. Now let's go to the EC2 instance tab, whether our instances that are created through auto scaling group were running or not. Now currently I am having 2 instances that we have created manually. Now let's refresh over here. Here we can see 2 more instances were added. These 2 instances were created through auto scaling group. These 2 are still in initializing state. Now meanwhile let's go to load balancer and copy that URL and we'll create Route 53 record in Route 53 service and access our application through Route 53 DNS name. Now go to load balancer. Click on load balancer name. Copy this DNS name. Now search here Route 53. Click on hosted zone. Click on hosted zone name. I have previously made a video on how to register a domain and how to purchase a domain in Hostinger. Now here we can see I have 2 existing records while I am providing my authorization to the Route 53 service from Hostinger. Now click on create record. So these are the settings to create a record. Now here we have to select a record type. We can see multiple record types. I am going to create a name record. This A-name record is used to route traffic to an IPv4 address and some AWS resources. As we are accessing our application server through load balancer service, we have to go with A-name record type. So here we have to select alias and we have to choose the endpoint to alias to application and classic load balancer. We have to select the region, AP South one. Now here we have to choose the load balancer. This is the load balancer that we have created. Now click on create records. Here we can see A type record was created successfully. Now select this record. Here we have information about the record. This is the record name. Here this is the value and the URL of the load balancer. So copy this record name. So when we are pasted the domain name, we are able to access our application. So continue to site. Here we can see we are able to access our application through our domain name. So once I am refresh this page, we'll get different IPs. Now we'll get 4 different type of IPs as we have configured 2 servers from auto scaling group and 2 from manual creation. Now this is the one IP 3-54, 11-103, 24-184 and 33-163. 1, 2, 3, 4. Now here we can see one of the VM that is created through auto scaling group. It is 24.184 as private IP, 24-184. And if we select another VM that is created through auto scaling group, it is 33.163, and here we can see it is 33-163. And for these two VMs we have seen earlier. So this is the scenario where in real time we'll use auto scaling group and load balancer like this to scale our instances and terminate our instances as per the load getting from the end users. The main purpose to use auto scaling group is to reduce the cloud cost by creating and terminating the instances. So this is all about this demo. And once you are done with your practical session, make sure you are deleting all the resources that you have created on cloud, or else you'll be get charged. So that's all for now. Thank you.